Hope everyone had not too much trouble getting stuff started. I know that Zoom is having issues right now, as well as Moodle is also having issues right now. So this is definitely a great start to your first year here. I would say it's not, stuff like this doesn't normally happen, but unfortunately, with all the technology issues going on, moving online is a bit of a hassle. So you probably will encounter some issues as we get started to the fall semester. We did switch mid-semester in spring, but a good amount of courses still had in-person components. Not everything was online. So you might, experience some more troubles, but hopefully this should be the bulk of it. And I hope that everyone got the chance to look over the course website. So there's some Zoom etiquette pointers on there. But briefly to just review what I had written for the Zoom etiquette so that everyone knows how hopefully we can run these calls well is basically one is to keep yourself muted unless you're going to actively speak. So if you're going to ask a question or something, then feel free to unmute. But otherwise, it helps prevent background noise. If you want to ask a question or something like that, feel free to use the chat. So in the Zoom program, there's a little chat button you can click and it'll bring up the chat. And then you can either type your question there or say that you have a question, then I'll just say, hey, what's your question? Then you can unmute and ask your question. Sometimes it's a bit easier to do it over voice. And then lastly, if you have a webcam, then I ask that you do turn on video. It does help to keep people engaged. Of course, if you need to go do something or if you have something going on in the background, feel free to stop your video, but otherwise it does help to encourage engagement. So the hardest part, I think, for moving online for everyone, especially for first-year new students, is going to be getting used to doing online work. It's a lot more self-motivated and self-oriented. You don't have the peer pressure of being in a classroom to pay attention, everything like that. And so it's going to be on you, right? So I think the easiest way to do that is to just sort of try to be as engaged as possible. I know it's going to be difficult, but that would be my best tip. And this is coming from someone who has been in university for nearly 6 years. So it definitely is still, hard for me to do as well. But we're going to go ahead and get on with the first lecture. If anyone wants to follow along with the lecture notes, I will be sharing my screen. But if you also want to copy the lecture, I'll go ahead and post this in the chat. I do try to upload my lectures here before the actual lecture start. But let me go ahead and share my screen here. Okay. All right. Hopefully people can see this. If not, give me a thumbs down. Okay. All right. So this is going to be the first year seminar, and this is the topic applications of computer science. So my name is Arun. You can just call me Arun. And today I'm going to go over an introduction to the course as well as talk about the topics that we're going to talk about in this course. So this is section 16, which is 10 to 11. I also have a section 14 from 125 to 215. So you'll probably see emails for both of them. I'm trying to group them together. So to be going along the same content, same pace. So about what this is. So first year seminars are designed to introduce new students to the CS program here at UMass and to start integrating you into the wonderful environment that we have here in the program. So this topic, which is applications of computer science, which I'll probably usually refer to as just CS, is a bit shorter, was an idea that I introduced in another course that was primarily taught to first and second year, some third year students, and all of them found it very helpful. So I coined this to the department and I thought it was a good idea. But essentially, may come as a surprise, maybe you pick this degree out of thinking, computer science is probably not related to the science of computers, a very employable area, but CS is a very general degree. We have tons of applications, I personally know people who work with robots in healthcare. I had a friend who went to go work for several months in Japan in elderly care, right? Fully funded to go work on making, robots there to help people with Alzheimer's and dementia, right? You can be a network engineer. You can work on the backbone of the internet, at some company or for research, however you want. You can design software that's used in space shuttles. I have a friend who works at SpaceX and works on the systems there, right? And I personally know these people who do these exact things, right? Any of these things, if they sound interesting, you could definitely do them. So one question that I want to pose to people that you're not probably going to know the answer yet. I thought I knew the answer when I started my bachelor's degree, but it turns out I really didn't. And that question is, what do you want to do with your degrees, right? You're kind of told, well, you're going to complete school, and then you're going to go to university, and then you're going to get a degree, and then you're going to go out into the world. Well, what does that mean, right? Like, how do you go from point A to point B? It's like, they're trying to tell you how to draw an owl, and they say, draw a point and then draw the rest of the owl. Like you got to have some more dots to connect. And so that's kind of what I'm trying to do with this course is help you find the answers to those questions, help you connect those dots for yourself. I'm not going to tell you, all the answers, because I don't know them. They're specific to you. They're your answers. And so what I want to do is I want to provide you with the tools to be able to answer these questions. Just a brief bit about me, to why am I qualified to bring this up and try to teach this to people. So I'm a PhD student. I did my bachelor's degree in computer science here, as well as my master's degree here. Computer science was a minor in math. I've written and I've taught 3 courses in the CS program here. And I've done both industry and research work. I have done work at Facebook as a security engineer. I've done research work in Japan in industry with internet service provider companies. So I've written and I've taught most of the content this course has before, and people seemed to receive it pretty well. I got good feedback off of it. So the idea is that I want to provide the same experience for all of you. So what are we going to cover in this course? First and foremost, the thing that sets this course a bit apart from others is that I want you to be able to decide, right? Generally, this course is for you, right? It's going to change over time. There are going to be new fields. There are going to be changes in the job market, right? The market right now is completely different from what it looked like in, May, even January. People graduate this fall, for example, they're going to have a completely different experience from people graduating this spring, right? I have friends who had internships set up and then companies just cancel on them because of COVID, right? Stuff like this happens, and you kind of need to be aware of those changes. And so the idea is that I want to have a dynamic course that matches what you're going to experience throughout your degree and when you finish your degree, right? My part to you is to present a variety of topics and then see what you all most want to learn about. So it is important because we only have 12 lectures on Moodle or 12 lectures outside of this one to cover important topics. So prioritization is going to be very important in there. The idea is that I've done two surveys similar to this before when I've taught a course. And basically what I'll do is I'll put up a survey on Moodle when it is back online and I'm able to access it again. So hopefully that'll be up by midweek. I'm expecting for it to be up later today, but I will send out an email when it's up. And then I'll just ask that you complete that survey, 5 minutes max by Friday evening. That's it. So I'll basically just have lists of topics there and you can vote on them. And I'll have little links if in case you want to, say, I don't really know what this means. Can I learn a little bit more about it? You can click that and then you'll just vote. You can as well type any suggestions in the survey if you have them. If you have a topic that you found while browsing around the web and you say, this would be pretty cool, then just let me know. So now I'm just going to go over a brief bit about the course logistics itself. So the course webpage is here, which was sent out in the initial email, which clearly you got as you're here. Basically, this is the course webpage. It's broken up into 3 sections. So this is the syllabus. By the way, if you do have questions, notes, comments about anything in the course, anything, not related to the course, I'm happy to provide, advisory input. If you have a question or something and your advisor's not doing great at answering it, I know that they have a lot of students to try and advise in this time. Just feel free to send me an email. I'd be happy to help. So note about why this course topic exists, right? So sort of already went over the second point, but basically I want to build and present a bunch of knowledge to you guys about the field of computer science, about how you would go about getting this degree, what you need in order to do that, what you can use it for, and what you can and should do during your degree and after your degree in order to set yourself up for a nice life, right? Because that's the idea. That's what you want to do with your degree here, right? You want to be able to live well. And most importantly, what I want to try and convey is how to do the things you can and should do. You know, lots of people are like, oh, you should do an internship. Oh, you should, you know, do applications to employers during your like, you know, junior year. You should try and intern so that you can get a degree or a job afterwards. You should consider grad school. You should, you know, do whatever. And it's like, cool, but why and how, right? It's, again, it's, you know, expecting you to do things that you don't know how to do yet, right? And the thing is, yeah, you can go and try to figure it out, but it's much easier if someone who's gone through it can convey it to you, right? Then you don't have to try and figure everything out for yourselves. And lots of it is trial and error. And so I'm trying to take out a good bit of the error part, right? You only have, you know, around 4 years to do your bachelor's degree. And those 4 years need to be used importantly, right? So if you're trying to go, say, for a tech job at Google or Facebook or Microsoft, right? You have to keep in mind that there are hundreds of thousands of people like you who want to do the same thing, right? And these companies can't employ all of them. So what you need to do is use these 4 years to your advantage to try and set yourself apart from them, right? And that's sort of the idea. As per the grading of the course, so I call them really assignments, but they're just small written response questions that'll require, you know, 150 to 300 words. Should take you no more than 20 minutes. But I'll have 5 of these throughout the course. More info will come on them a bit later. I don't have any for the next 2 weeks. And all you need to do is you need to just submit 4 out of 5 of these. Make sure you answer the question, whatever's being addressed, and have the word limit or meet the word requirements, and then you get an A for the course. That's it, right? Assuming that you do less than that, I say submit 3 out of 5, that would be a B, and you know, 2 out of 5 would be a C, so on, right? So I think this is pretty fair. All you really need to do is do 4 out of 5. You know, if you find one that you have a bit slammed and you can't really do it, that's fine. You know, feel free to skip it. If you don't really know the answers to one yet, that's fine. You know, you can put that or skip it. It's all good with me, right? As per attendance, so I do expect that everyone attend the lectures if their time and location allows for it. I know that we have people in different time zones. You know, we might have someone here who's 7:23 in the morning right now in California. And if you are here at 7:23 a.m., I commend you. But I know we also have people who are on the opposite side of the world, you know, working out of China or India, and time zones can be very hard that way. So if you are unable to make it, that's fine. I will be posting the recorded lectures online, and there's the lecture notes as well. But if you are able to make it, then I do ask that you come to each and every one. It is a lot easier, again, to encourage that engagement. And I feel that this is useful information that I wish I would have had going through the degree. So hopefully, you know, you'll feel the same and sort of be encouraged to come from, you know, your own drive. We already went over the Zoom etiquette, and there's not really much of a chance to do any sort of cheating in this course, but you know, if for some reason you find a way to do that with the written response questions, you want to like share a response with your friend. I mean, it's going to be tailored towards you. It's going to be your thoughts and your opinions, what I asked for in the written responses. So, but basically don't share them to submit to someone else, right? Don't copy just off of an internet page. You know, it's not going to help you. So this is meant for you, right? As for the schedule, so I have this all as TBD because I have all the topics, but we don't have the priority in ordering yet, right? So that's what we're going to do this week, and then I'll have this page uploaded by probably Friday evening to Saturday morning, right? And then again, the lecture notes are going to be here, added before lectures, so that you can follow along. So does anyone have any questions about the course layout, course content, anything like that so far? I'm going to break down into topics after this, so if about topics, then I can go over those, but if anyone has something, then do feel free to let me know. Again, you can use the chat to note that you have a question, or just type your question in the chat. So broadly, I'm going to organize the topics of this course into 3 sections. So first, I'm going to talk about, well, not necessarily first, this ordering is going to be subject to change, but those areas are the fields of computer science, which I'm going to go over about a good bit of them now after this. The uses of the CS degrees, and this is going to include things like employability in industry, how you do internships, how you write a resume, all that stuff. And then tools for success. So this is going to be things like how do you generally organize yourself for classes? This is going to be things like, what sort of development tools can I use in computer science to make my courses easier to do, right? How can I make this flow better? So those kinds of things would be in tools for success. But if there are other topics that you want covered, you're more than welcome to suggest them. There are definitely things that I could, skip on. So when I cover a field, I'm going to, in this course, be describing the area, the history of the field, where it's at today, what kinds of applications you have in the field. And I'm going to demonstrate some fun ones as well. As an example, when we talk about computer vision, I was thinking about demonstrating a model that learns how to play Mario, right? What the job market looks like for this field and what it's expected to look like when you finish your degree, right? And then I'm also going to go over the course progression here at UMass. So if you are interested in doing something in this field, then you can be able to look at these courses as ones you might want to take, right? So I'm going to go over some fields that you might expect to see. And each one of these will be voted on, but this is just a brief summary so you kind of figure out what it's a bit about. And after the votes, then we'll be able to decide what sort of ones we want to cover in what order. And each one of them should have their own lecture to them, possibly sometimes, 2 topics to 1 lecture, depending on how big it is. So first is the buzzword of the, I guess, millennia for computer science, which is artificial intelligence, right? And machine learning. So artificial intelligence, which is a superset of machine learning, and you'll typically see these referred to as AI and ML. It's about creating machines that are supposed to be able to reason on their own. And usually what we do as a basis for this, because we can't really create machines that, have independent thought yet, is to use this combination of search algorithms or game theory and sensory inputs. So I'll be going over game theory a bit more later, but an example is that you create a robot, right? And it's supposed to be a path-finding robot, right? It's supposed to find the optimal path from point A to point B, right? And in order to do that, it would use a search algorithm, right? And this would appear to be some sort of intelligence to it, right? It's able to see that this is where it needs to go and find the best path to get there, right? And so there's no such thing as like, a general AI, of like HAL 9000 or whatever it is out of a TV show. That doesn't exist yet. And I don't know if that will exist in the next, 100 to 500 years. But where we are at is we can definitely create robots or machines to solve these smaller on the surface, but definitely large problems. So an example that I think is going to come up later in this lecture again is I have a friend who works on robots in Amazon warehouses. And this guy gets paid a lot to basically determine the most optimal paths that robots can take when moving packages along a floor in order to get from not just point A to point B, but avoid other robots moving, avoid humans walking, avoid obstacles that happen, try to avoid creating obstacles, and be the most time efficient on this, because you still have to remember that, it's a business and time matters. Whereas when we talk about machine learning, which is a subset of artificial intelligence, this is about taking input and learning with or without human feedback. And this feedback is usually called supervised, right? So if it's with human feedback, it's supervised learning. Without it, be unsupervised learning. And what this wants to do is just transform some sort of input into a type of output. So really the most basic example for this is linear regression, right? You have a bunch of points, right? Say you have a bunch of these green points and a bunch of red points, right? And you want to put a new point on this graph and then have your model tell you whether it's going to be red or green, right? Basically, whether it's on in this red cluster. And so in order to do that, we have this model that so really what this is about is function approximation, right? The base assumption is that everything is modeled after some learnable function, some data, right? A pretty good example that is used a lot is something medical-wise. And so an example that I think is pretty relevant is flu, right? So you take a data set of millions of flu symptoms from millions of people. And the idea is that given a person's symptoms, you want to determine the probability that they have flu, right? And that is machine learning, right? You're essentially teaching some algorithm, right? To take this input data of these flu symptoms and then tell you the probability that someone has flu. And these function approximators, in case you've never heard the word classifier before, those are called classifiers. So again, one you've already used, hopefully in math, is linear regression. Another would be like quadratic regression, right? Or logistic regression. So the next that is sort of a branch off of AI as well is computer vision. So this is about taking visual input and identifying objects. So a very common example now of computer vision is self-driving cars, right? So you want to take some road sign, apply a variety of transformations to it, and then determine, say, if it's a speed limit sign, what's the speed limit, right? Or if it's like a stop sign, how far away is it? So this kinds of stuff is all in this subset of computer vision. And an example here on the right is image segmentation. So the idea is that you want to be able to pick out objects from images, right? Fun fact is this is what you're doing whenever you complete like Google's reCAPTCHAs. You're really just providing more data for their supervised algorithm. You are the supervisor in that case, right? Trying to teach that algorithm. And there's natural language processing, which is also considered this subset of AI. And this is about understanding and generating human language. And this is a very hot area recently, particularly in the space of digital assistants, right? You have lots and lots and lots of data for being able to help to help people, right? Say that you want to be able to search the internet for something, from your voice. You're cooking and you want to specify what's this measurement or how can I cook whatever. Well, that's fundamentally understood by this by techniques in this field of natural language processing, right? It's also a very big area in the reverse operation, right? You have different speech being said and you want to try and understand it and then say mine data in the background. So that's also a very common, unfortunately, area, right? You're speaking by your phone about something and then all of a sudden it shows up in your Amazon, recommendations list. So, but really NLP is not just about translating speech to text. Really, truly understanding the meaning of speech is a significantly harder problem and one that is tried to be sought after. So as an example, say that you are finding tweets about Trump on Twitter, right? And you want to be able to determine whether those are positive or negative towards Trump or towards policies, right? How would you even start to go about doing that, right? You could maybe try and find negative words like bad or not, or I don't know, what other bad words? I guess I'm not really great with words. Poor or something like that, right? Negative words in general. But what if you come across some negator, right? Like not. So you could say not poor. Well, that would be positive, right? And so you have lots of these combinations of what you can actually find. So it's actually very hard to be able to determine what someone is saying. Even then you have misspellings and you have improper grammar or you have commas that change the meaning of a sentence, right? And so all these things are very hard to understand. Here, for example, I have this little flow of generally how this process would go, where you take this lexical analysis, which is where you're analyzing the lexicons of a sentence, for example. So you're breaking up the sentence into smaller chunks and maybe taking just stems of words. And then you're performing a further analyses. So you're maybe trying to figure out the meaning of a sentence or whatnot. And then you would have this output that you transform it from using this database of all these words and all these meanings, right? And it's sort of hard to encapsulate, but a general process is that you would pre-process these words, these sentences, do some transformations, and then try to have some output from that. So going into different areas, so there's sort of, I guess, three main areas in computer science. Really, there's regarded as artificial intelligence or machine learning as one area. Then there's systems, which includes anything to do with networks or security or software. And then there's also theory, which is covered a little bit later in this, but that's more about like algorithms or data structures. Right? So this would be in a systems area, which is software and reverse engineering. So these are meant to encapsulate two ideas that are the reverse processes of each other. So the first is software engineering. So you have, and it's actually its own field because it's not that easy to write scalable programs, right? As programs grow in size and complexity, this process of building a program becomes significantly more difficult. And it's not, you know, sometimes it's not just cost effective to throw more computing power at the problem, right? Sometimes it is, but sometimes it's not. And so in that way, you need to be able to develop software that is efficient and understandable. And that is actually a big problem because there's a lot of algorithms that can't be solved efficiently, right? And so part of the problem of engineers is to try and figure out ways that they maybe can reorient the problem to solve it in a more efficient way. An example, right, is if you want to develop an interface for a trading system such that anyone can use it, right? This presents a bunch of different problem areas, right? This is a trading system, meaning that milliseconds, microseconds for transactions matter. So you need to have efficiency, you know, incredible speed and efficiency in your program, right? Just like an extra statement that checks something could be the difference between someone making $1 million or like $1, right? You need to have an interface that works for people, that they just understand and they can navigate through it quickly. Because again, if they take an extra half a second to click a button, that's the difference in a trade, right? And so there's a lot of these problems that can come up in this side of the software that really doesn't seem all that, you know, relevant at the start of when you're thinking about it. You know, I think you might just be like, well, all I really need to do is be able to buy and sell, you know, shares of something. Well, it's not actually that simple, right? There's a lot more to it. Reverse engineering is generally the backwards of this. You have some finished software and you want to analyze it. You want to break it down, see how it works, right? A large part of security is reverse engineering, right? When you find some malware, you don't have access to the source code of that malware, right? You can't just see how it was written. So you need to try and understand it by breaking down the software. Then going into the theory sort of space, there's algorithms and there's data structures, and these two go hand in hand. So generally, an algorithm is a process for solving a problem, right? Step-by-step process. So as you have more complex problems, understandably, that process is going to get more and more complex. You know, if you're describing an algorithm for how to make a sandwich, it's pretty simple. But if you're describing an algorithm for getting to the moon, a lot more problems involved in that, right? So it is incredibly important to design these algorithms efficiently, right? You need to respect the processing power that you have. You need to respect the available memory you have. You need to respect the amount of space that someone's computer has. You know, if you're doing something on a phone, that's going to change versus if you're doing it on a desktop, right? The processing power is much more heavy on a desktop, right? You can also respect disk space that way, right? Someone's phone might only have, you know, 64 gigs of storage, whereas a desktop might have a terabyte, right? And so really what this makes the field about is about finding efficient and fast ways to solve problems, right? A cool example that I like to go over is this fun topic called genetic algorithms, right? So what this theory about genetic algorithms is that, well, you know, we have this theory of evolution where you have some organism that changes over time by having different parents, and the offspring will acquire new traits and features, and we see how well it behaves, how well it survives, right? How well it performs in the environment. And genetic algorithms follow the same exact process, right? You take some bit and then you flip it, right? And or you take, you know, some different combination of qualities about a program and you change them, and then you just sort of derive that into a new version, and you see out of a bunch of new children which one performs the best, and whichever one performs the best, you continue the same process with that one, right? And it's pretty cool. So a lot of them are used in, say, games for actually modeling evolution, right? Data structures go hand in hand with algorithms. So the idea with data structures is that you want to develop efficient ways to organize, to store, recall, and manipulate data. And this goes with algorithms because usually what can happen is some data will be in a format that is unworkable for an algorithm. But by changing the format of that data, you can develop an efficient algorithm for that problem. as well, as you will find out in CS187, which is data structures. Some algorithms are generalized to work with specific data structures, right? So oftentimes you can solve problems just by changing the format of the data, right? And then databases are also in the space of data structures. So this is really about storing, manipulating, and then recalling large amounts of data. I don't mean, large like a couple terabytes. I mean large like petabytes of data. Like I mean data on billions of people, right? Facebook has over 2 billion users, right? They have to store a lot and move a lot of data. The figure roughly for 1%, 0.1% of their computing power each year and moving all that data around is $4 million for 0.1% of that, right? Like that's a lot of processing power. Then still in the area of systems, we have networking. So this is about communication, right? This is about information flow. And one of the most sort of fun areas for me that I think about in networking is unreliability, right? So networks are often unreliable, right? At random times, your Wi-Fi might go down. And if you're playing a game at that time, how do you think the game engineers design that to be able to handle your network going down? That's not really a problem that you would normally think about at the very onset, but definitely you would come across that if someone's just like in point A and then they're suddenly at point B, right? You don't want them to just be able to do that. At the same time, a fun, solution or a fun problem to think about is interstellar communication, right? Say you're trying to transmit data from Pluto to Earth, right? How do you know that the same data you sent from Pluto to Earth, like the same data that you sent is the same data you received at Earth, right? There's tons and tons of things that can interfere with that information on the way. It could run into asteroids that scatter off the information. It could run into, cosmic radiation or whatever things impact it, right? And if you're using certain, infrared or whatever, then maybe there's other infrared light that's interfering with that. So there's a lot of these impactors that you can have on data, right? And so you want to make sure that the data is the same that you receive, right? So that's a fun area to think about. And that brings us into cryptography, which is about translating data into another form that's unreadable. And then optionally, oftentimes you do want to be able to do this, is transferring it back into a readable form. So an example is, you log into a website. They don't just store your password in a database somewhere, right? They store an encrypted version of your password. They want it so that, if someone obtains that database, they don't get access to your password. And that's important. Oftentimes you hear about, security breaches and then all of a sudden a different account on a different platform gets hacked. Well, the reason is because they were storing your password insecurely and someone took that password and was able to use it to log into another service because you use the same password, right? Cryptography oftentimes goes a lot with networking to try and send data securely over networks, right? Without fear that it's going to be intercepted by someone malicious and modified. And the last I have to talk about is robotics and game theory, which I mentioned a bit earlier. So robotics is obviously works with robots. So it's really about developing and controlling robots, and is done mainly in two ways: autonomously, which is on their own, and then manually with human input. And this is tricky, so you can run into hard problems. As I said, I had a friend who worked in this Amazon warehouse, and an example, right, is multi-agent path planning. So if you have robots moving around each other in a warehouse and they want to move optimally, how would this scale as you add more robots? Are they allowed to communicate with each other, or do they just have to use sensors to find each other? How would this work when a human just shows up out of nowhere, right? Do you have a sensor placed in the right location? If you have like a sensor on the very front of a robot and the robot is this long and a human's, this long, it would be a while before they would hit the center of the sensor, right? So that's that element of unpredictability, which is pretty fun to integrate. And then game theory is, I think it's something that's thrown around a lot without really being understood what it is. So really game theory is about making choices when agents involved are rational. And what that means is that you want the agents involved to either be people or to be made by people to be rational, right? They They want some objective to win something or to get something out of this, right? So an example that's very commonly used that you'll probably hear about, and maybe CS 311, I think is when it's brought up. Two people are accused of a crime, right? If one person confesses and the other one doesn't, the confessor is released and the other spends 20 years in prison, right? If neither confess, both spend a year in prison, okay? If both confess, both will spend 10 years in prison and they cannot communicate. What would you choose, right? So the idea is that, all right, we'll give you the choice. You can rat out your friend, right? But if you do that and they also rat on you, then you spend 10 years in prison, okay? If you do that and they don't rat on you, then you spend no time in prison and they spend 20 years in prison, right? But if both of you stay quiet, then both of you will spend a year in prison, right? Obviously, the optimal choice is for neither one to confess, right? Because then they'll only both spend a year in prison. But can you really trust someone, right? Because you have to think both people in this are rational, both want to spend as little time as possible. And so therefore, would both maybe choose to confess, right? Because they hope that the other person doesn't, and then they'll spend no time in prison. But then you have to think, well, what if they're thinking the same thing as me, right? Then they'll confess and then we'll both spend 10 years in prison. So it's actually a pretty hard problem when you think about it. The optimal solution is very evident, but in practice, what people will do is different. A more complicated example, optimally playing games like chess or Go, right? Chess has billions upon billions of possible move combinations that can happen, right? And therefore, playing that optimally is actually a very hard problem. You can't make a machine that can 100% beat a human 100% of the time yet, right? Maybe at some point in the future that'll happen, but all the best ones right now that are able to sort of come close to that just do it literally off of calculating all the possible combinations that they can go, and trying to take the best one out of it. And you know, they just throw more and more compute power at that, right? But ultimately that comes down to game theory. So if you have any questions about fields so far, so that's sort of going to be the main chunk of talking about topics. I'm going to talk briefly about the other types of topics that we might cover. But this essentially is designed to introduce you a bit to what fields are out there, a little bit about each one, so that when you take this survey that you'll hopefully know a little bit more about what each thing will mean, and that help you rank things. But if anyone does have a question, you'll feel free to interrupt or put in the chat. So the other two areas that I wanted to cover. So first is going to be the degree uses. And this will include things like how to get internships, what internships really are, you know, where you can do them, when you should apply, what you need to apply, right? Things like what can you do after your degree? You know, if you want to be an engineer, if you want to be a researcher, you know, what types of engineering positions are there? You know, you hear someone works at Google, cool. There's like a bajillion jobs that you can do at Google, right? We'll talk about grad school, right? Some people find that they want to do a master's degree and they want to go work, or they want to do a PhD and go be a professor or something, right? Talk about resumes and CVs, which resumes are used in industry, CVs are used in academia. We'll talk about the dreaded coding interviews, which I don't know if any of you have heard about them yet, but they are regarded as a not fun part of doing a CS degree and getting a CS job. And basically the idea is that when you go and apply to do an internship or you apply to work at a company, they want to test and make sure that you can actually code. And so they will have you live code for them on a whiteboard in an interview. And if you don't do well enough, they won't hire you. And majority of the time, people don't do well enough, right? I think I would say it's probably, I don't know the statistics on it, but I would say it's greater than a 70% failure rate very easily. And so it takes a lot of practice to be able to do these things well, right? Just like anything else, you need to be able to practice it. It's a skill. We'll talk about tips for doing these job applications to make you stand out from other people. Things you should start doing now, you know, this year, and then things you should do throughout your degree to try and help you achieve your goals with being able to use your degree. Other topics. So there's useful tools. So these are things like, I'm not sure if any of you heard of LaTeX before, but I hadn't before I started a bachelor's degree. I learned about it, you know, probably about halfway through my first year. And this is about, say, like typesetting documents. So it's making better resumes or being able to easily write math homework without using Microsoft Word, right? There's development tools. So not just, the actual development environments you use or the code editor you use, but the operating system that you choose to use. Maybe someone wants to use Mac or Windows or Linux, right? Why would you choose to use each one, right? Why would you choose one over the other? So topics like that, right? And there's some generally some more things that I think are applicable wider to the rest of your time here, which is organization software. How do you stay organized, keep track of your classes, keep track of the things you need to do, right? Security tools, right? How do you stay secure while you're doing all that? You have lots of different platforms that you want to try and use here. How do you stay secure? Make sure you're doing them, so that you don't have something happen, lose your data or get hacked or something like that, right? And productivity applications. So lots of applications you can try and use to optimize your workflow to make things be able to be done faster, right? Back in the CS realm, we have version control software. So people probably have already heard of GitHub to an extent, where you distribute software from. So I'll talk a bit about that and how that works. And then I also want to cover, as students, everyone likes free stuff, and there's lots of things out there for computer science students that you can actually try for free or get for free entirely, that you should definitely try and take advantage of. Lots of them are meant to help you in personal projects, which help you stand out from other people. So that's the bulk of today's lecture, though. So does anyone have any questions about these topics? Essentially, I'll have you vote on these in the survey, and then we can start really with digging into stuff next week. Okay. I will stay through the rest of the call if anyone has any questions or wants to ask for input about something, or if you say, hey, I'm in these two courses, I want to drop one of them, which one should I drop, which one's easier? I can answer these questions about math, CS, generally anything in STEM. I can talk about pretty much any undergrad requirement. I did my degree here, so I've been through it already. But otherwise, that's really all I've got. So, thank you for registering the course. Glad you find it interesting. If you have any questions, please do talk to me. Just email me, or you can ask before, after lecture, or ask during lecture. My goal really here is to help you all learn useful material. There's lots of other first-year seminars that are fun and interesting. There's things like brain teasers and things like AI for good, right, and stuff like that. And I think those are really cool. But I think that there's a lot of content that I could teach you guys in this course that isn't covered elsewhere that you definitely should know that will help you a lot and give you an advantage. So that's sort of what I want to do here. And if you feel like that's not happening for you, we get 3 weeks in and you feel like, hey, this isn't useful for me, or halfway through, hey, I found this thing that I think should be covered, otherwise I don't think it's really that useful, then just email me, right? Just ask me, and I'd be happy to modify the course to adapt to you guys as we go along. So in general, please let me know if I can do anything that will be able to help you succeed. If you have any questions, degree, about program, whatever, right? Just feel free to ask me. Otherwise, next time we're going to go over the survey results, and we're going to start on the main course content. So we'll see which we're going to do first. It could be that we decide to go over, the fields first. It could be we go over this sort of internships or something else first. It could be going over organization tools first. So we'll prioritize and see what people will want to go over first, right? But otherwise, hope you guys have a great rest of your day. I don't know if anyone has lectures so far, or if you have more lectures later on today, but hopefully we'll have tech issues resolved as it goes along. I don't know if Zoom login was working yet. It wasn't working at the start of the class for me, but we'll see how it goes. But yeah, that's all I've got. So thanks very much again, and hope you guys have a great start to your semester. I'll be around on the call until 11.